Hello guys, how are you doing? Let me talk to you doing good. Today we shall be discussing about the Type C power supply. That is how the Type C ports or the Type C chargers um, send the voltage into the motherboard. How these adapters supply the voltage. Here with me, I have several of the motherboards. I have a Dell here. This is the latitude. As you can see, it contains a Type C port at this side, and also this also side contain a port for the Type C. Apart from that, we'll also be discussing about this other motherboard here. This is the Spectra motherboard. It also contains the two ports for the Type C. And then again, here I have another one. This is the that G7 motherboard. It contains also the two Type C ports. Yes, as you can see, I have the two Type Cs. And also this one contains the blue pin. So here we'll have more than two power supply ports. You have the two Type Cs and the one blue pin. So before we continue, uh, in case you haven't subscribed to this channel, please, I'm still requesting you, please subscribe to it, share with your friends, because we shall be sharing a lot of content concerning laptop repair. In case you are interested in learning about the laptops, in case you want to have this skill, please subscribe to this channel, watch our tutorials, and share with your friends. We also teach, in case you want to learn, you want to enroll to acquire the laptop repair skills, you are highly welcome. And in case also you have a problem with your laptop, please, we do repair laptops, so you can also send to us. Our contact details they are in my bio, so you can contact me. You can so that we can uh, discuss the logistics, how we will receive your machine, or how you will send us your computer in case it has an issue. Still, we have a lot. We have a lot to do. That's why I don't want to waste more of your time. We are going straight to the business of today. I've done showing you the illustration of what is happening uh, about the Type C power supply within the laptop motherboard. I'll be drawing the illustration of exactly what happens so that you can understand uh, uh, theoretically and in a practical way. So let's go straight to the business of today. So let's start. So here we have Type C power supply. So this is Type C power supply in a laptop motherboard. So first of all, because as you can see, this motherboard has just shown you it contains two Type C power ports. So I'll be illustrating the two Type C. So in case you are, let's assume we have a port A here. So this is a Type C port A. Then here we also have a port A. This is another Type C. This is port P now. So these two ports supplies power into the motherboard. This one will have a positive voltage here. So this is a positive line. Then past here we'll have a power fuse. After power fuse, we will have a switch. This is the MOSFET, first MOSFET. Then we will also have second MOSFET. Then we'll have a line going towards the motherboard. This same line also we have with these ports because these are the same type C. So we'll have a positive line. This positive line, first we'll have a power fuse. After power fuse, we'll have the switch, another switch. Then from here, the two lines meets here. Then after mixed up, they'll connect to a power resistor. So this is power resistor 1. So again, you might have the two switches. That is MOSFET 1 in case you're using this line, and MOSFET 2 in case you're using this line. This one is the power inductor or the power fuse. So this is PQ1. Let's call it PQ1B for this. Then PQ2B for this line. Then here, so this is BL, PL1B, then this one will be BL1A, then this one will be BQ1A, then BQ1, BQP, BQ2A, right? Yes. Sometimes you might have more than two MOSFETs. So we'll have the first MOSFET in this line, we'll have the second MOSFET, then the third MOSFET. So sometimes you can find it has 6 MOSFET, that is 1, 2, 3 for A and 1, 2, 3 for B. I'll be explaining actually what is happening in case we have more than 2 MOSFETs within that line. So other than that, so obviously we'll have the ground. So we'll have the ground connecting to the ground. So this is the ground. Still with this one, we'll have the ground within that line. Good. So these two type C ports are controlled by what's called BD controller. It contains what's called BD controller. BD controller. These are power delivery controller called TPS. So the type C power supplies. So sorry for that. Yes. The type C power supply are controlled by an IC called TPS. That IC is what negotiates the voltages going from the type C into the motherboard. The standard voltage going into motherboard is 19 or about 20 voltage. So those voltages need to be negotiated from the power adapter then into the laptop motherboard. And that role is done by the BD controller, which is called TPS. That IC is located somewhere between the two. It can be either here. So we'll have an IC either here, this point. We can have that IC either here. So this IC is the TPS, or you can have it somewhere just around there. So that's a TPS controller. This IC is directly connected. I don't know whether I can use a different pen. Let me try this one. I don't know whether it will be feasible enough. So this IC is connected here. Is connected to that port. It's not visible enough, so let me just use mine. So just make sure you pay attention to what I am writing, because I believe at the end of the day we'll have so many writings here which you might get confused. So we'll have that port connected to the TPS. Same with this one. We'll have the same connection. We'll have the same connection, the TPS. Yes. So in case you plug in your Type C adapter here, the TPS will negotiate that voltage because we need 19 voltage uh, into the motherboard, and all those negotiations are done by the TPS. In case you have a faulty TPS, that's when you can have when you plug in your adapter. This adapter you will have 5 voltage. And that 5 voltage normally it's not coming from your adapter. It's coming from the main power line within the motherboard, right? Yes, I'll going to explain to you beyond here what are the components which are passed here and what those components does. In case you have an extra MOSFET here, maybe you have three MOSFETs along this line or 3 MOSFETs along this line. So what happens in case you're using this line, that's line A. When you plug in Type C in line A, we'll have a power switched from here to the next MOSFET, then next MOSFET, then that MOSFET, the main role, that MOSFET of this line will now function to protect the power from coming back to this other line. So we'll have the voltage going past here, past 2, then past that MOSFET, then into the current sense resistor. That voltage will go past here. Instead of now going back to B, it will be blocked by that MOSFET of this line. I don't know whether you are getting this. Actually, that MOSFET of this line will block the power coming from this other line. But that MOSFET from this line will block the power coming from the other line. So normally that MOSFETs prevent the backflow of voltage or power from going into this other direction. So for this one, in case it has 2 voltages, so this one will play the role of blocking power from coming back to line B. Right? Yes, let me trust you're getting, because I don't know how else I'll have to explain that for you to understand. Then past here, so we'll have the PR1, so this is a power resistor. So here we'll have now the main power being generated at the second phase here. So here what happens? What happens actually here, we'll have We'll have the two switches. We'll have the other MOSFETs here, which generates the main power line. Yes, it can be a double MOSFET, or it can be two MOSFETs here. These two MOSFETs, we will have an inductor connecting the two of them to the other two MOSFETs in the other side. Yes. So what happens here when this MOSFET is on? When this MOSFET is on, this one also will be on, and this one is connected to the ground. So this MOSFET is connected to the ground. Same case with this one. This one still is connected to the ground. So when this MOSFET is on, this one is on too. Because this one is the reverse, so it has a reverse voltage or the inverse. So meaning even this one will be turned on and this one will be turned on. Then meaning we'll have a positive voltage from this. And this is now the main power line generated from here. This is the main power line generated. And normally this power line is about 13 volts or 12, depending on how much the voltage are in the battery. So normally this inductor, most of the time it is inductor 2 or 2. So I'll be showing you in the motherboard about this inductor. So these MOSFETs, in case you have four of them, we'll have the gate of this MOSFET. We'll have the gate of this MOSFET. Then you'll have the gate of this one. Then the gate of this one. All these gates of these MOSFETs, all of them, even this one, connects to a power management IC. There's a power management IC here which controls this circuit. So we'll have a power management which controls this circuit. Yes, this circuit which generates the power line. That power management IC, it can either be the BQ IC. This one is very common, or it can be an intercell IC. It can be an intercell IC, that is ISL. Yes. So depending on the model of the laptop, you can either find this IC being an intercell or it can be the BQ. So this is what controls what? It controls this power. Still, this IC senses the current or controls the current after this resistor or before this resistor. So the voltage going past there is being also monitored by this BQ. It's good for this BQ to monitor the current which is going past here. In case if it is excess current, it will give instruction to these circuits to be turned off. So these switches will be turned off. That's why this BQ or this PMIC which controls this line needs to monitor the current going past this current sense resistor. That's why we have the voltage going in there and going past there. Then, in case you have excess, it can either order these circuits to be turned off, or it can order this TPS to it can shut down. Yes, let me just use it can shut down this TPS, or it can shut down this switch. Meaning this line, meaning this TPS also communicates with what? With this PMIC. Yes. So in short, we also have communication between the TPS and this BQ, right? Yes, I'll be showing you what exactly happens. So how really this communication happens, right? Yes. So other than that, we'll also have another IC, that is the EC. Here, I don't know whether I should throw it. Let me throw it there. So we'll have another here. We have another IC here. This IC is the EC. EC is the embedded controller. So this is the embedded controller. How is embedded written? Anyway, let me just call them EC, embedded controller. This EC now is what gives it controls. It gives the signal for enabling signals for this and this. It controls these two lines. It controls the BQ and what? And the PMIC. So meaning also we still have the communication between the TPS and the AC. We have communication between the BQ and the AC. And apart from this, we'll have the output voltage. So obvious we need the input voltage from the main power supply, which is 3.3. So the main voltage coming to the AC is 3.3. Then this chip, this EC is called the startup chip. This is the IC which switches on the laptop. So this one connects to the switch. So we have the switch, which is triggered by the AC. So in case you have a problem with your power remote, it can mean this AC also might be having an issue. Yes. At the same time, this EC controls the power flow or the power supply within the motherboard, not directly, not by uh, ensuring the transmission of voltage directly, but by enabling the signal for the TPS, the BQs, and any other power supply or power management I see within the motherboard. So let me show you exactly what happens within the motherboard. I'll be showing you one on one some of these components we just discussed. Yes, let's start with this motherboard. This motherboard, we have the motherboard for A30G7. As you can see, within this motherboard, I have the truth. I have more. Okay, let me start with the other one. We shall be coming to this because I can see this one it has more. It has more than two power supply. Okay. Anyway, after all, we need to discuss it. So this one, it has the two Type C and one blue pin. But our main attention, in case you have another port here, maybe you have another port. So that port, let me just draw it. That port will be here. So maybe you have an extra blue pin. So this is now a blue pin. Those are the Type Cs. So these are the Type Cs. Then the blue pin will have the connection with the power inductor or the power fuse. We'll have the first switch or the first MOSFET for the blue pin, the second MOSFET for the blue pin. Then past here, it will also join the main line, right? Yes, it will join the main line, then to the PR1. So let's have a look at, sorry for that, guys. So let's have a look at this. So here with me, we have Type C, then we have the blue pin. At this line, let's start with this line for the blue pin. As you can see this line here, let me just bring it closer to you so that you can see it clearly. As you can see, I have this line. These are the power inductor. These are the inductors. We have switch 1, this one. Then you have switch 2, this one. This is the switch number 2, this one. Then past here, we should have the joining in. So past here, you can see here I have some dots. So it means this one, this line has gone to the back. So it meaning these are the joining points, these are the meeting points. Then, so meaning this line is coming from somewhere else. So for this other line, let me place it this way. For this line of this Type C, their MOSFET is this one. This is their first MOSFET. Then along this power lane, we'll have the second MOSFET here. Then past that MOSFET, we'll have the meeting point. These are the dots, so meaning it goes at the back. This other port, you will have first MOSFET, second MOSFET, meeting point. So meaning past here, because I am not seeing any resistor here and I am not seeing any connection, so meaning it is either at the back or somewhere with it at the back. Here, let's have a look at the TPS. Where is the TPS? I am not seeing here. Maybe it's at the back. Yes, which I see is this. This is different. This is not for the. Yes, it is at the back. You can see this is the back of the controller. So it is the back. Then you can see this line going this way to the resistor. Then pass the resistor this way. So you'll have the resistor, then you have now the four MOSFETs. So this MOSFET I drew here, 1, 2, 3, 4. 1, 2, 3, 4. You have two big resistors and small resistors. I'm trying to locate the TPS. I'm trying to locate the TPS. I don't know where they placed it. Yes, here it is. This is the TPS. This student TPS. So this is the TPS. Then here, this line, it came where? It was here. Then it goes this way. Here, I am not seeing the power management for this circuit. So if it is not at this side of this board, it will be at the back. As you can see here, I have this is intersil 9241H. Intersil 9240. So this is the PMIC you are trying to locate this one. Now it contains the intersil. So we are done with that. Let's have a look at this other motherboard. Let's have a look at this other motherboard. So this is the other motherboard. This is for the Spectra. I can see I have the two ports here. These are the two ports for the blue pin. Yes. At this side, I am not seeing any controller, but I can see the main power lane running this way. So probably, maybe I have those components at this side. Yes, here are they. This is the TPS. This is the TPS. Here I have two lines for the Type C. 1, 2, 3. I have three MOSFETs. 1, 2, 3. I have three MOSFETs at this line. So this one contains the three MOSFETs. Past there, let me believe I have another line at the back. As you can see at the back you have a big track here. So it means this is the main power lane. Sorry for that. So this is the main power lane. It goes this way, all the way, all the way, all the way until you will have what? PR1. This is the power resistor 1. We'll have the power resistor here. Then after there, I'll have the four MOSFET. 1, 2, 3. Maybe the other one is at the back. Wow, this power supply is so funny. And there is the controller. There is the power controller. Here is the power controller. In fact, these are the lines for that. 1, 2, 3, 4. Yes, these are them. Then you have 9241H. This is still another. This is the BMIC for this motherboard. So let me show you another one. Let's have a look at this one. So this is the Dell. So let me just remove this tape. I placed it here during today in the morning hours. I was working on this motherboard. Yes, and this motherboard I had a problem with the TPS, so I removed it and I placed it somewhere. So it's here at the back. I placed the TPS. I removed it. I don't know whether you can see it was inside below this heatsink. So I don't want to remove the heatsink for now. So here I had this is the Type C for this port. It supplies power past there. Then you'll have the inductor, the power fuse. MOSFET 1, MOSFET 2. As you can see, the line is going this way. Then you will have the dot, so meaning it is connected to the back. Yes, then it can connect this other port. So this other port also, you have port from this other side. Inductor, MOSFET 1, MOSFET 2. Still, it connects to the main line. Yes, the TPS I removed from the other side. Where is the power management I see? The power management I see, maybe it is this other side. Yes, we can locate it. Yes, this is the power management IC. Here are the two MOSFETs. However, this one now, I don't know whether you can see. You have one, two. As you can see, you might think it is two MOSFET. These are not two. This is two in one. That's why it's called dual MOSFET. So this one carries the two circuits. For example, this one. Then this one carries the two of them. Do the others. This one. That's why it's called the dual MOSFET. So you can have the dual MOSFET or one MOSFET. So the middle of the MOSFET is what connects the two switches. So this is dual MOSFET, dual MOSFET. The controller I see is here at the back. This is Intersil 9538CH. Yes, that's the controller for that line. And then finally, I don't know whether you've ever seen this. I have another motherboard here, the last one. This last motherboard, it contains the Type C ports. Yes, these are the ports. Yes, the ports are here. Below this, let me just remove this. Yes, these are the Type C ports, the two of them. Then this is the TPS for that line. This is the TPS for that line. Other than the TPS, we need to have the two power supplies. Yes, maybe it's at the back. And of course, these are the line which generates the main power. These are the line for the Type C. 1, 2, 3, 4. So two lines and two lines. Then it converges here at this PR1. So it converges here. It is sent directly to this unit 2R2. As you can see, this inductor, this is the 2R2 inductor, this one. Then in between the two R2, in the sides of the 2R2 inductor, you'll have the two switches and the two switches, which generates the main power line. Then we'll have the main power line from there. Yes. Then past there, into the motherboard. We'll have the EC chip. You can see the EC chip is not connected directly to the main power line. However, it has the input voltage of 3.3, but this one controls these PMICs by setting up the signals and instructions for this to operate. So guys, thank you so much. I know we've taken a lot of time discussing about the Type C power supply. So let me trust at least you understood something. Yeah. I don't know whether I showed you the TPS for this one. I don't know whether we did. Oh, okay. I remember showing you below at this other side. I had removed the TPS earlier because that was the shorted component. So I just placed an order for that chip. So I'll be waiting for that chip so that I can replace. So guys, thank you so much for being patient with me, and let me trust at least you understood something about the Type C power supply. Yes, and we shall be seeing each other in our next video. Well, have a beautiful day and see you in the next video. Goodbye.